The law of sines is very dependent on a triangle that's labeled in this way. Little a, which is a side, is opposite big A, which is an angle. Big B and little b, big C and little c. The interesting thing about the law of sines is you don't really need to know how to manipulate equations or work with identities that deal with the law of sines, or sine in general, the function. The only thing you really need to know is how to calculate sine of an angle, manipulate an equation just using numbers, and how to use second sine on your calculator in degree mode. So I'd like to tell you exactly what the law of sines is. And the law of sines is based on the triangle that we just saw, ABC with angles ABC opposite sides ABC. So we have a triangle with this particular situation set up. We have two sets of equations. We have sine angle A over side A is equal to sine of angle B over side B, which is equal to sine of C over side C. That is the mathematical truth. Now, these equations right here is what equations we would use to solve for an actual angle. I'll tell you a little bit more about that later. We also have little a, or side A, over sine of A, which is equal to B over sine of B, which is equal to C over sine of C. And these equations are the ones that you would use to solve for a side. Okay? So one other thing is when a triangle is given, the problem is just a simple calculation. So if we have a triangle that's given like ABC here and we know a few of the angles and we know one of the sides, then it's just using the formula, really, and that's it. And we're just calculating things. So you set things up and you ultimately solve it on the calculator. Now when a triangle is not given, the main challenge is sketching. Really, it's just how do I actually sketch this triangle to solve the situation with the triangles. So I have some information I'm going to give you, and I'll show you how to actually sketch the triangle in an objective way so that when you're talking about the math, you can relate to somebody else who's sketching the same triangle. I'll say one more thing before we get started with an example, and it's this. If we have basically these equations up in purple here. We're not actually going to solve all three of these equations in one. We'll either solve, this pair or this pair over here, or A and C together. So we're always given some situation where we know the angle and the opposite side. And same goes for the blue equations down here. Now, if you remember in geometry class, there were these congruence theorems that were like ASA and AAS, side, 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 and side, angle, side. Those are four main ones. Now, these two are the ones that are basically used in the law of sines. We know that angle, side, angle, and angle, angle, side produce only one triangle with information given. And it's because you're forced to sketch the triangle in a certain way. Same goes for side, 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 and side, angle, side. Those are used in law of cosines, which is the next topic. But there's one more, and it's side, side, angle. Now that's an ambiguous case. It works sometimes, but not all the time. And that's why it's not a theorem. So tomorrow, or the next video that you watch, is basically going to be all about side, side, angle and how to work with that situation. But for now, I'd like to just show you how to sketch the triangle in this situation. So we have A equals 38 and B equals 46. Now, I just want to clarify as well, just because I sketched this triangle A, B, C from left to right, that doesn't mean we're sketching those angles always in that order. What I like to do is just sketch the angles in the order that they're given to me. So here goes. First up, sketch the angles and complete the diagram. So here goes. What I'd like to do is just kind of pretend that there is a ground floor here. We're outside sketching this triangle, and this is the ground. And then I'm sketching this so I could see what a 90-degree angle looks like. And we could use a protractor, but it's not really necessary. Now, here goes angle A, which is 38 degrees. Slightly less than 45, So here's approximately angle A. And since an angle is two rays together, I'll sketch the bottom of that. So that's 38 degrees. Now I don't know how far I should go, but I'm just basically letting my paper or my notepad limit me in some sort of way. How much space do I have on the paper? But you don't want to write this too small. You want to create your triangle bigger than you think it should go. So the next thing that we'll do is angle B is 46. And again, if it was angle C here, I would sketch angle C next. And I'm continuing where I left off. Continue off from this point. Now I'll sketch a 90-degree angle for reference, sort of. That's good enough. Now I'm creating an angle that's bigger than the previous one, but basically half of 90. So I'm going just slicing right down the middle here, sort of best that I can do without a protractor. And that angle is B, which is 46. Now you may be inclined to actually sketch or write down what this angle C is, what the angle measure is, but that's part of our next step process. All I want you to see right now, well, first we can kind of erase this stuff, is that we were forced to sketch the triangle in a certain way here. This point that was created where angle C is was forced to intersect with that original ray that I created from angle A. Opposite angle A is little a, which happens to be 9, and opposite big B is little b, not a 6. So that, I think, is the best way to sketch the triangle when we're given the information, just like above. So now notice that we have angle, angle, side. The next step, which is fairly simple, is just to calculate the missing angle. So angle C is equal to, so we're basically solving this triangle, is what we're doing. Angle C, there's a total of 180 degrees for the triangle, and we're subtracting the sum of 38 plus 46. So this is something that you would show on paper to prove that you know what you're doing. So 180 minus 84 is 96. Aha! 96! That kind of looks like the angle that I sketched, because I was just being fairly careful with what I was doing. Now notice that we have all of the angles, so we're just looking for the value of C and B now, which is fairly simple. So I'm going to go back to the law of sines, and in blue here it says use these ones to find the sides. It's basically the law flipped upside down, but we use it that way so we don't have to manipulate the equations too much. So little a over sine of a. So I'll use the a's, so little a, which is 9, over sine of a. This is basically our reference. It's our ratio that's creating the ratio of the sides to the angles. And I'm going to randomly choose B as what I'd like to solve for next. So I'm just solving for B over sine of big B, which is 46. So notice that in this equation, if we're solving for B, what we'd have to do is multiply by sine of 46. So I get on the left side 9 sine 46 over sine of 38. I write that on paper on this iPad so that the next step that I take is just right in the calculator. I'm typing it exactly as I see it, closing parentheses in degree mode. And when I do that, I calculate that and I get B equals 10.5. Well, I get a few extra decimal places, but for the most part, one decimal place is good and tenths. All right, so now we would do the same thing for side C, but we would still use that 9 over sine 38. The reason is if we use B now, it's actually an estimate of the situation, so we want to use the original information. So repeat for side C. Well, if you haven't, I'd like you to actually calculate that on your calculator so you can confirm that you know how to punch those buttons and you could get the correct answer. And if you work C, I believe C is something like 14.3. Hey, that's all there is to the first part of the law of sines, angle side angle or angle angle side. And the next part is focusing on a little bit more difficult concept, but I think it's unique and interesting, and we end up getting a really cool looking picture. Alrighty, hey, thanks for watching.